So this is the last part of the lesson in which we are going over a summary, a Stoic summary. So always what you will have some given and some that they are asking for. So you will have some given here and some that they are asking for, which are unknown. Okay, now the given may be in terms of grams, maybe in terms of the concentration, so molarity, or maybe in terms of liters, volume. So grams, mass, this is mass. Molarity is moles per liter, and volume is in liters. This grams is that is known as the gravimetric Stoic. Molarity is the solution, and a volume is dealing with gas. So in order to go to moles, because this is the main important thing that we want to do, is to move to given moles. So now, when we have the mass in grams of the given, in order to find the given moles, what we will do is we will use molar mass. When we have the molarity, what we will do is we will use, to find the moles, we will use concentration. And when we have the volume and we will want to use, find the given moles, then we have three options. If it is STP conditions, SATP conditions, or ideal gas law. So one of them we will use it. One of the things, which in other words is using molar volume. Finding molar volume. And if it is an STP, then it's 22.4. If it is an, say, TP, 24.8. And if you're using ideal gas law, then we'll be using, starting with the R value and then canceling out. As you have the given moles, in order to move to the moles of unknown, so all this work here is to move to given moles. And when you have the, you have to move to moles on unknown, then what we will use always is molar ratio. So this will be moles of unknown. And then again, if they are asking for grams, for mass, then you will use molar mass. If they are asking for concentration, then you will use molarity. If they are asking for liters or concentration, you will use molarity. And if they are asking for volume on the gas state, then you either will use STP, SATP, or ideal gas law to find volume. So this is kind of a summary of the Stoic. Now, here is a nicer picture. So again, if they are giving you grams, because the whole point is to find the moles of known. If we know moles of known and we have a balanced chemical reaction, using molar ratio, we will be able to move to moles of known, and then deal with whatever situation we have. Okay, so now when the whole point is to find the moles of known. If they are giving grams, then we will use the molar mass. If they are giving molarity, then we will use our moles over liters. And if they are giving you liters, then you will use PV and or nRT for ideal gas, or 22.4 for STP, or if it is SATP, then you will use 28.4 or 24.8. It's 24.8, sorry. It's 24.8. That are the molar volume of gases. And then we go molar ratio. Then we move to moles of unknown. And then from there, again, whatever they are asking for. If they're asking for grams, then we will do grams. If they're asking for liter, then we will use PV and RT, or 22.4 or 24.8. If they are asking for molarity, then we will use the fact that concentration is moles per liters. So let's take a look now to this example. 27 milliliters of 0.500 molarity of silver nitrate is combined with 14.5 milliliter of lithium sulfate. Determine the concentration of lithium sulfate and determine the mass of precipitate form. Okay, so like everything, we will start with a balanced chemical reaction. So will be 2, 3 in aqueous state plus lithium sulfate, and in aqueous state is producing lithium nitrate plus silver sulfate. And we know that this is the precipitate because it is in solid state. So now see what we have. We have a molarity of silver nitrate of 0.500 moles per liter. And we have 27 milliliters. And what we are doing, then what else is given here is combined with 14.5 milliliter of lithium sulfate. And what we are looking is determine the concentration. So concentration is question mark. Good. Well, as I have said, like I usually write the molar masses, but let's not for now. So we'll start with what is given. 27 milliliters of silver nitrate. Let's convert it into liters. Why do we need to convert it into liters? It's because we silver nitrate, everything is into liters. Is 1 liter of silver nitrate. So milliliters and milliliters is canceled out. And the whole point, as I said, is to move to moles. The connection between liters and moles in solution, this is solution, how do we know? It's moles per liter, is the concentration. So that the concentration given is telling us that in 1 liter, we have 0.500 moles of silver nitrate. Or if we have a concentration of 0.500, then 1 liter then we have to have 0.500 moles of silver nitrate into 1 liter. So 1 liter of silver nitrate has 0.500 moles of silver nitrate. So now liters and liters is canceled out. And what do we have up to this point is the moles of silver nitrate. Now we will move to the moles of the unknown. And that means that we will figure out what is the molar ratio between silver nitrate and lithium sulfate. And the molar ratio is 2 to 1. So 2 moles of silver nitrate needs to react with 1 mole of lithium sulfate. Or if we have 1 mole of lithium sulfate, then it needs to react with 2 moles of silver nitrate. So 2 moles of silver nitrate needs 1 mole of lithium sulfate. So moles of silver nitrate is canceled out. And we are looking for concentration. Concentration is moles per liter. And in this case, what we have is 14.5 milliliters of lithium sulfate, which means that we will have 1 over 14.5 milliliters of lithium sulfate. But this is not what we express the concentration. The concentration is moles per liters. So let's convert the milliliters into liters. 1,000 milliliters of lithium sulfate is 1 liter of lithium sulfate. So milliliters and milliliters of lithium sulfate is cancelled out. Now, in terms of the numbers, what do we have here is 27 times 1 times 0.500 times 1 times 1 times 1,000 over 1,000 times 1 times 2 times 14.5. And the units are moles of lithium sulfate over liters, which is the concentration of lithium sulfate. And when you enter this in your calculator, you should have a number that is 0.464 molarity of lithium sulfate. And this is taking into consideration the number of SIGDICs. Okay, and now when we are finding the mass of the precipitate formed, then what we will do is we will see which one is finishing first, which of the reactants is finishing first. In other words, which one is silver nitrate or lithium sulfate is excess or limited reactant. So in order to figure out which one is limited or excess reactant, the best way is to do Stoich. So there are 2 things that you can do. You practice when we are working with the figuring out which one is limited or which one is excess reactant. There are 2 things that we practice. The first one is that we practice doing Stoich, and the second one is that we we figure out whatever is the limit in the reactant and what is the mass of the precipitant. So I will rewrite the chemical or the balanced chemical reaction again, so that we can write all the information that it's either figured out or it's given in our problem. So lithium nitrate Okay, so now what was given was that the molarity of silver nitrate is 0,500 and volume is 27 milliliters, which you can write 0.027 liters. And then what is given here is that the volume is 0.10145 milliliters. Liters. And what we found is that the concentration is 0.464 molarity. And we are looking for grams of silver nitrate. How do we know that we are looking for grams of silver nitrate? Because we are we know that this is the precipitant. So that is what it will be precipitated from the reaction. Now, on this stage, I will add the molar mass. So molar mass of silver nitrate. Why? Because as soon as I'm moving to moles, in order to find the grams, then we will need the molar mass of silver nitrate. Now, the molar mass of silver nitrate is you have 2 silver, 1 sulfur, and 4 oxygen, and it is 203.94 grams per mole. So I will start first doing Stoich as what is the mass of a precipitant for silver sulfate when we suppose that we know only silver nitrate, and then the second Stoich for lithium sulfate. So we'll start with the Stoich using as a starting point silver nitrate. So 0.027 liters of silver nitrate. Now, the whole point is to find the moles, because then we use the concentration. 1 liter of silver nitrate is 0.500 moles of silver nitrate. So this will give us moles of silver nitrate. And then we are moving from silver nitrate to silver sulfate. Okay, so the ratio is, molar ratio is 1 to 2. So 1 mole of silver sulfate is produced when 2 moles of silver nitrate are used. So moles of silver nitrate is cancelled out. Now that we have moles of silver nitrate, then using the molar mass, we can find out how many grams of silver sulfate is produced. So using the molar mass, 1 mole of silver sulfate is 203 grams of silver sulfate. So now moles of silver sulfate is cancelled out, and we are ending up with grams of silver sulfate, which is 1.38 grams of silver sulfate. And now we will work between the lithium sulfate and silver sulfate. Okay, so we'll do pretty much the same process with the starting with lithium sulfate. So we'll go 0.0145 liters of lithium sulfate using the molarity that we just found, 1 liter of lithium sulfate, 0.464 moles of lithium sulfate. Now we have the moles of the known, and we will, using the molar ratio, we will find the moles of the unknown, and in this case is 1 on 1, because 1 mole here and 1 mole is here. So the coefficients are 1. It doesn't really matter. When the coefficients are the same, doesn't really matter which one you are using, but for the sake of the process, 1 mole of lithium sulfate and 1 mole of silver sulfate. So moles of lithium sulfate is cancelled out. And now using the molar mass, 1 mole of silver sulfate is 203.94 grams of silver sulfate. And when you're entering in your calculator, what you will enter is 0.0145 times 0.464 times 203.94, the whole thing divided by 1. So then we have 1.37 grams of silver sulfate. So you have 2 informations here. One of that is when the silver nitrate is not reacting, but because both of them are reacting, but one that silver nitrate is reacting, and the other one that silver lithium sulfate is reacting. The first one is telling you that the amount that is produced is 1.38 grams of silver sulfate. And when you are starting with lithium sulfate, then 1.37 grams of silver sulfate is produced. That means that in this reaction, the limited reagent is lithium sulfate. This is limited reagent. And silver nitrate is excess reagent. And as a result of this, the amount in those conditions, the amount of precipitate produced is 1.37 grams of silver sulfate. Okay, we will deal with those type of questions even more in class. This finally concludes the lesson 2, and we will stay on this lesson for a long time.